Hello and welcome back to Faceless Security, where we explore the world of technology and cybersecurity. In today's video, we are going to discuss quantitative and qualitative risk analysis, then compare both of them. In this section, we're diving into quantitative risk analysis, a crucial method for assessing and managing risks with numerical precision. What is quantitative risk analysis? Quantitative risk analysis evaluates the probability and impact of identified risks numerically. It quantifies risks in terms of monetary value, time, or other measurable factors. The goal is to provide a clear understanding of potential risks and their financial impact, enabling data-driven decision-making. Key component of quantitative risk analysis. First, risk identification. Identify potential risks that could impact the project's objectives through brainstorming, expert judgment, and historical data analysis. Next, probability and impact assessment. Assess the likelihood of each risk and its potential impact using statistical methods and historical data. Data collection and modeling. Collect data related to identified risks such as historical loss data, expert estimates, and project-specific factors to build a risk model. Monetary valuation. Assign a monetary value to the potential impact of each risk to understand the financial implications. Risk aggregation. Aggregate individual risk impacts to get a comprehensive view of the total potential risk exposure using techniques like Monte Carlo simulation. Decision-making. Use quantified risk data to make informed decisions about risk mitigation, transfer, acceptance, or avoidance. One of the key techniques in quantitative risk analysis is the expected monetary value, or EMV. It's calculated as probability times impact. Let's dive into an example calculation. Consider a project with an identified risk of a data breach. The probability of this risk occurring is 20% or 0.2. The potential impact of this risk is $50,000. To calculate the expected monetary value, or EMV, we multiply the probability by the impact. So EMV equals 0.2 times $50,000. That gives us an EMV of $10,000. So the expected monetary value of the data breach risk is $10,000. This figure helps in understanding the potential financial impact and prioritizing risk mitigation efforts. Tools and techniques. Expected monetary value, or EMV, calculates the average outcome of scenarios that may or may not happen. It's probability times impact. Sensitivity analysis assesses how different variables impact a particular outcome, identifying the most significant risks. Monte Carlo simulation uses random sampling and statistical modeling to estimate the probability of different outcomes, helping to understand the range and likelihood of risks. Decision trees model decisions and their possible consequences, including risks, costs, and benefits, helping to visualize and analyze complex scenarios. Benefits of quantitative risk analysis. Quantitative analysis provides precise data, enabling more informed and objective decisions. By assigning monetary values to risks, organizations better understand financial impacts and allocate resources effectively. Prioritize risks based on their potential impact and likelihood, ensuring critical risks are addressed first. Proactively manage risk by identifying potential threats early and planning appropriate mitigation strategies. Challenges and considerations. Accurate analysis requires high-quality, relevant data, which can be challenging to obtain. Quantitative methods can be complex, and may require specialized knowledge and tools. Despite precision, there is always some uncertainty. It's essential to account for this in the analysis. Quantitative risk analysis can be resource-intensive, requiring significant time and effort. Quantitative risk analysis is a powerful tool for managing risks with numerical precision. By understanding its key components, tools, benefits, and challenges, organizations can enhance their risk management practices and make more informed decisions. In this section, we're exploring qualitative risk analysis, an essential method for evaluating risks using descriptive and subjective data. Qualitative risk analysis evaluates the probability and impact of risks using descriptive scales rather than numerical data. It prioritizes risks based on their severity and likelihood. The aim is to prioritize risks for further analysis or action by assessing their impact on project objectives. Key components of quantitative risk analysis. First, risk identification. Identify potential risks through methods such as brainstorming sessions, expert judgment, SWOT analysis, and historical data review. Next, risk probability and impact assessment. Evaluate the likelihood and impact of each identified risk using a predefined scale, often ranging from very low to very high. Risk ranking and prioritization. Rank the risks based on their assessed probability and impact to prioritize them for further action. This helps focus resources on the most significant risks. Risk matrix development. Develop a risk matrix to visually plot risks according to their probability and impact, facilitating easier prioritization and decision-making. How to perform qualitative risk analysis. Use various techniques to gather information about potential risks, involving key stakeholders and subject matter experts. Assess the likelihood of each risk occurring and its potential impact on project objectives. Use a consistent scale to ensure comparability, typically 1 to 5 or descriptive terms. Very low, low, medium, high, very high. Prioritize the risks by combining the probability and impact assessments. High probability and high impact risks are typically addressed first. Create a risk matrix to visualize the prioritization of risks. Plot risks on a grid where one axis represents probability and the other represents impact. Example of qualitative risk analysis. Let's consider a software development project where we identify several potential risks. We'll assess and prioritize these risks qualitatively. Identified risks: data breach, project delay, scope creep. Probability and impact assessment of data breach: probability, high. Impact, very high. Project delay probability, medium. Impact, high. Scope creep probability, low. Impact, medium. Risk prioritization. In this example, the data breach is the highest priority due to its high probability and very high impact, followed by project delay and scope creep. The risk matrix will show the data breach in the high probability, high impact quadrant, guiding our focus towards mitigating this risk first. Benefits of qualitative risk analysis. Qualitative analysis is quicker and easier to perform than quantitative analysis, making it ideal for initial risk assessments. Broad stakeholder involvement engages a wide range of stakeholders in the risk assessment process, leveraging diverse perspectives and expertise. Flexibility, adaptable to various projects and organizational contexts with customizable scales and assessment criteria. Focus on critical risks. Helps identify and prioritize critical risk early, enabling proactive management and resource allocation. Challenges and considerations. Subjectivity relies on subjective judgments, which can introduce bias and inconsistency in risk assessments. Lack of precision does not provide the numerical precision of quantitative methods, which can limit its usefulness for detailed risk analysis. Limited depth may not be sufficient for complex or high-stakes projects where detailed quantitative analysis is required. The accuracy of assessments depends heavily on the knowledge and experience of the participants. Qualitative risk analysis is a valuable tool for quickly assessing and prioritizing risks based on their probability and impact. By understanding its key components, benefits, and challenges, organizations can effectively manage risks and allocate resources where they are needed most. In this section, we'll review quantitative and qualitative risk analysis, then break down their differences, benefits, and use cases. Quantitative risk analysis involves assessing risks using numerical values and statistical methods to estimate their impact and likelihood. It aims to provide a measurable and objective assessment of risks. Common methods include Monte Carlo simulations, decision tree analysis, sensitivity analysis, and fault tree analysis. Qualitative risk analysis involves assessing risks based on their characteristics and impacts using non-numerical methods. It focuses on identifying, prioritizing, and understanding risks without assigning numerical values. Common methods include risk matrices, expert judgment, SWOT analysis, and Delphi technique. Quantitative risk analysis focuses on numerical precision. Here are its key characteristics. Objective assessment uses numerical data and statistical models for analysis. Risk quantification assigns specific numerical values to likelihood and impact. Data-driven requires accurate and detailed data for effective analysis. Predictive power provides precise risk estimates and potential financial impacts. Meanwhile, qualitative risk analysis focuses on descriptive aspects of risks. Here are some key characteristics. Subjective assessment relies on the judgment and expertise of individuals. Risk categorization uses categories such as high, medium, and low to describe risk levels. Ease of use simple to implement and requires less data. Flexibility adaptable to different scenarios and environments. Now, let's look at a quantitative risk analysis example for a financial investment project. In this scenario, we are assessing the financial impact of market fluctuations on a portfolio. The method involves using Monte Carlo simulations to model different market scenarios and their probabilities. The outcome provides precise financial risk estimates, such as the potential loss in portfolio value under adverse market conditions. Then let's consider a qualitative risk analysis example for a new software development project. In this scenario, we are identifying potential risks in a new software development project. The method involves using a risk matrix to categorize risk based on likelihood and impact. The outcome is that high-risk items are prioritized for mitigation, such as potential delays due to staffing issues and technology compatibility concerns. So, what are the pros and cons of each risk analysis? Quantitative risk analysis provides precise and objective risk assessments, data-driven with high predictive power. Also useful for detailed financial and project risk analysis. But it requires significant data and resources. Quantitative risk analysis also can be complex and requires specialized skills. May not be adaptable to all scenarios. Meanwhile, qualitative risk analysis is easy to understand and communicate, requires less data and resources, flexible, and adaptable to different scenarios. But it is subjective and prone to biases. Less precise and lacks numerical detail. Limited predictive power. In summary, both qualitative and quantitative risk analyses have their strengths and weaknesses. Qualitative approaches are best for initial assessments and scenarios with limited data, while quantitative methods excel in providing precise, data-driven risk assessments. Understanding when and how to use each approach is key to effective risk management. Thank you for watching. Be sure to like, comment, and subscribe for more great content from Faceless Security.